Hi there, we are Team HomoSapiens. We are going to solve the biggest flaw in the generative AI in this era. So our model is the HEGES secure AI proxy layer. So our model is all about that. So the user, we all are living in the untrusted spaces. No, we are not living, I'm sorry. The AI models are living with us as we are untrusted. So our high performance proxy layer is filled with the four stage layers, and our main innovative layer is the Hell Max Disruptor ring buffer, which is a ONNX which is a ONNX model. ONNX model is nothing but an open neural network exchange model. It's a machine learning model, which is the most standardized format to solve the hardware and the software problems. So we are inculcating that. And coming to the stage one is nothing but a deterministic filters, which includes Bloom filters. We use Bloom filter algorithm and REGex. REGex is a simple search pattern matching algorithm, which is pre-trained model. So this stage one solves the 80% of the problem, which is nothing but a direct prompt instruction. These kind of problems, uh, you know, these kind of problems will be solved using the stage one layer, and the stage two layer is all about the privacy layer. Privacy layer is not only for the it should not only be provided for the AI model. According to us, privacy layer should also be provided for the users who are legitimately, I would like to quote this, who are legitimately using the AI models, because those data can also be leaked. Those can also be leaked. So we have to anomalize it. So for stopping it, we will be inculcating the privacy 2.0 layer, which automatically identifies the text. So it identifies the text like personal details or names, or if email contains email IDs, numbers, personal details. So it will just identify all those terms and convert those into alphabets like X, Y, Z, or username, like that. For example, if the email includes that John has sent you an email, so that John will be converted into user ID. So just that AI will not be aware of your personal details, which is also one of the important component with which should be solved for the future use case of this generative AI era. And coming to the stage three, which is the super important stage, which is uh, not easy. It's a reinforcement stage where we are inculcating the intent classification. As I already quoted, we'll be using the uh, SLM, small language model, which is nothing but a ONNX runtime. It's a using ONNX runtime will make it easier to deploy the train, and will also train that model specifically using the Stilbert flexible models. It will train that model specifically for that. As I already quoted, in the stage one, 80% of the task is done, but at the stage three, the indirect prompt instructions, the complicated prompt instructions will be caught over there, which is the, so as we are using the digital bird, which is a RNN, uh, which is a RNN, which is a model, will be using it. So we'll be using RNN, which is a recurrent neural network model. It's a deep learning model. So as I said, we'll be inculcating the Distilbert uh, model, which is mainly specified for text classifications. It will classify the text, which will be automatically uploaded. As I said, it's a reinforcement learning layer. The model should be trained such that it will be learning. It will be relearning through the user feedback, user positive feedbacks. So using that, it will be the SLM, the small language model, will be very flexible to run on the CPUs. And the stage for the core innovation, the Canary token, which really stands out our ideation is that we give the canary tokens, as the there are a lot of advanced techniques or indirect prompt injections or anything. If a user tries to inject prompt using websites, web scraping is one of the important algorithms for AI model to run. We have a lot of algorithms like retrieval augmented generations. So to when these all are being evolving, maybe in future for the website, the blogs, and for their views or for their recommendation, for their personal growth, they may go to any extent. So we'll be using canary tokens. Canary tokens are nothing but the tokens. So these tokens are generated by UUID identifiers, which is nothing but a universally unique identifier. It's a 128 bit number, uniquely identified information for computer systems. It's a 36 character string, which is separated by hyphens. So we generate these universal unique identifiers, so which are nothing but a tokens. So these tokens, using that algorithm will generate tokens. So that tokens will be passed to through our API proxy layer for the LLM model with the user prompt. That will be passed through to the LLM with the user prompt. And after processing that specific token, the model should give back the response, and it should give for that specific response, it should give back its token for the our proxy layer, quoting that it's legitimate. It's like giving the token and and keeping your stuff out there, and returning back again, showing the token and returning back. So it's like a simple process where the model is given the unique code. It takes the prompt, it processes the prompt, and it looks for the output, and it gives the output, and returns back that token, that canary token, to our AI proxy model. So, it's a small SLM, as I said, as I coded initially, it's SLM. So that show, if those matches, that shows, that will be correctly, that output will not be flagged. Otherwise, that output will be flagged. That output will not be sent to the user space. So that output will be flagged. So the idea is all about this. These canary tokens will make sure that every proxies or every injections, any kind of injections will be stopped out here, will be